We're going to try to do some dimensional analysis, which is just a fancy way of saying converting units. Alright, and there's actually some basic ones, an intermediate one, and sort of semi-advanced problems. So I have this separated in Schoology so that you can kind of see a variety of dimensional analysis problems. Now, again, it's just a fancy way of saying unit conversion, and that's why we have a relationship chart right here. Now, if you weren't with us during class, then I'll show you as I'm doing the problem how to use this chart. So, for example, in this first problem right here, it says, let's see, it says, if someone measures 0.0025 grams of vitamin A on a scale, how much is this in micrograms? So that thing that looks kind of like a backwards U, or a sideways U, I guess, is micro, okay? And we're actually going to need this relationship from the chart in order to help us. So to use the chart, we can get the relationship for micrograms and grams just by looking at where micro is and literally writing grams right next to it. So microgram. A microgram is related to a gram because 1 microgram is equal to this many grams. Okay? So that's the relationship. And it'd be a helpful idea to write down these relationships as you're going. So 1 microgram is equal to 0.000001 gram. And this space right here, it's just there so that it's easier to recognize how many zeros there are. There's no other significance to it. So 1 microgram is a small amount of grams basically. So how do you go about solving for this? We always start with the number that we're given in the problem. So it's saying here we have this many grams. That's what we're going to start with. Okay, we have that many grams. And now to convert that grams, the grams that we have right here, into micrograms, we draw a time sign, and we're going to do something that looks like a fraction. So there's going to be something that goes on top of this and something that goes on the bottom. Now the thing that goes on the top and the bottom are going to literally come from this relationship. Okay, we can only write these two things in a numerator or a denominator. So the thing is, if we're starting with grams in this work right here, then that means we have to write grams on the bottom as well. And the only thing that has grams in our relationship is right here, grams, 0.000001 grams. So we're going to write this part on the bottom, okay? Okay, and that means that on the top of this fraction, we're going to write the other part of the relationship, 1 microgram, okay? Because that's the only thing that's left. Okay, and if you did your reading, you're going to know that this thing that looks like a fraction, it's actually called a conversion factor. And all a conversion factor is it's a relationship but written as a fraction, okay? So that's what a conversion factor is. And when you now look at what we have right here, there's going to be a unit that cancels out exactly, okay? So we have grams and grams right here. Those will cancel out. But this one right here does not cancel out because it's not grams. It's micrograms. So that one is actually just left right there. And that's good because the question is asking us to convert to micrograms, right? So since we're left with micrograms, that's a good thing. That means we checked our work. This equation makes sense. So we're going to go ahead and now type this in the calculator. So what we have here is 0.0025, okay? And then since there's a 1 on the top, you can times 1, and then that would be 0.0025 on top, right? And then the thing that we have on the bottom, there's only one thing that's on the bottom, so that goes on the bottom. And it stays like that, right? And then the unit, of course, is micrograms. Now, this is still a fraction, right? It's still a fraction, so I want to complete this answer. Alright, to complete the answer, with a fraction, all you have to do is divide the top number by the bottom number. So let's go ahead and type this out. We have 0.0025 divided by 0.000001. Okay, and what I'm getting on my calculator is this, 2,500, and the unit is micrograms. Okay, so that should be the first answer, 2,500 micrograms. For this one, the next problem, number 2, you can try on your own. It's going to be very similar, and what you're going to do is you're basically going to convert from one unit to the next using one single conversion factor, okay? So I'm going to let you try that, and then you can check on Schoology whether you got that answer correct or not by hovering over the hover over answer part, okay? Okay, so let's try this second problem under the intermediate portion. Now this one's intermediate because I'm going to tell you it requires multiple conversion factors, okay? So here's an example. If you had 5.2 centimeters of magnesium ribbon, how much is this in millimeters? Now for this one, we have centimeters and millimeters, just two prefixes. And I know you've done this before with, moving the decimals, but now we're going to do it, with the conversion factor method, just so that you get better at using dimensional analysis, basically. Okay, so we need a relationship that involves centimeters and millimeters, okay? Centimeters and millimeters, because those are the units that are in the problem. So that means we're actually going to look for two relationships from the chart, centimeters and millimeters, okay? I'm going to go ahead and erase what we have so far. Start with centimeters, okay? So if you write right here, centi, and then you just put m right here, centimeters, you can put m right here for meters. So for every 1 centimeter, that is equal to 0.01 meters. Okay, that's the first relationship that we need. 1 centimeter equals 0.01 meters. And then for the next one, same thing. Just put m right here because we want millimeters. For every 1 millimeters, there's 0.001 meters. Okay, these two relationships, I'm going to write it down right next to the question because they are important for how we're going to use the conversions, or how we're going to figure out what the conversion factors are. Okay, so I'm going to write both of these relationships on the bottom right next to the question. 1 centimeter is equal to 0.01 meter, and also 1 millimeter is equal to 0.001 meters. Okay, and then we just double check. Yep, so it's written, the relationship, centimeters and millimeters. Now we're gonna go ahead, start with what we're what is given in the problem. Okay, so there's only one number given in the problem. It's 5.2 centimeters. That's what we're gonna start with. Okay, and now we're gonna start converting. So we need to do the times, and we're gonna draw a line. And now something is gonna have to go on the bottom, and something is gonna have to go on the top. Okay, now just know that this conversion factor is only gonna come from one of these relationships. So we're just gonna pick the one that fits. Okay, and the thing that you should know is what unit goes on the bottom right here. It's supposed to match whatever unit is up here. The unit that we're starting with is centimeters, so the unit on the bottom has to be centimeters. And if you look at our conversion factors, the only one that has centimeters in it is this one right here. It has 1 centimeter. So I'm going to write 1 centimeter on the bottom. And since we're using the first conversion factor, for the top we're going to write the other thing, 0.01 meters. Okay, because 1 centimeter equals 0.01 meters. And if you take a look at it right now, there's something that can cancel out right away. Centimeters and centimeters. We are left with meters, But that is not what the question is asking us to stop at. Okay, we want to stop at millimeters. But that's okay because we can just draw in another times and a line. Okay, so for this one, this second conversion factor, you can imagine which relationship we're going to need to use. Alright, so remember, on the bottom of the conversion factor, it's what you started with from the previous one. So the previous one is 0.01 meters. So that means we want meters on the bottom of our second conversion factor. And the one that involves meters that we haven't used yet is this one right here. Okay, 0.001 meters, right? And then the one that we want on the top is the other part of that conversion factor, which has millimeters. Okay, so we're going to write millimeters on the top right there. 1 millimeter. And if you take a look at the units that cancel out here, it's going to be meters and meters. What we're left with is millimeters. And you can see that that's what we want to stop at. So that's good. We're at the unit that we want to stop at, and that means we can write in our equal sign. Okay, so now we're just gonna multiply out all the fractions here, and we've done that before, right? Just not with these units. So what goes on the top? On the top, we're gonna have 5.2 times 0.01 times 1. Okay, 5.2 times 0.01 times 1. So on the top, I'm getting 0.052. And on the bottom we just have 1 and 0.001. So 1 times 0.001 is going to be 0.001. So that's what we have on the bottom. Okay. Let's see. What do we do now? Let me go ahead and erase these circles. I forgot to erase it. So what do we do now? Okay, I'm going to write in the unit that did not cancel out. And we're going to simplify this. Okay, so we're going to simplify it. What we have is, on the top, 0.052 divided by 0.001. Okay, so 0.052 divided by 0.001. And what I'm getting is 52 millimeters. Okay, and there we go, 52 millimeters. Alright, and for this one, just know that we use 2 conversion factors because this problem involved 2 prefixes. Okay, so that means we need 2 relationships, 2 conversion factors. Okay, so for number 4, just as before, you can try this. Just know that since this is intermediate, you might need to do more than 1 conversion factor. Okay, this one you're going from milliliters to microliters. Okay, let's go ahead and try one of the advanced problems. Now the advanced problems, they're just advanced because you gotta think about it a little bit more. But they actually might not be that hard. So let's go ahead and try this. A metallurgist is someone who works with metal. A metallurgist is going to make an experimental alloy that requires adding 325 grams of bismuth to 2.500 kilograms of molten lead. What is the total mass of the mixture in kilograms? What is the total mass in kilograms? So we know that we need to add the 2 substances together, but it has to be in kilograms. So the one that is not in kilograms, this bismuth, we have to convert it to kilograms first, right? And then we can add it to the one that's already in kilograms so that we can get the total mass. So do this first, convert the grams to kilograms, and then you can add it to the kilograms that we have right here. That's the plan. So the first one, we need to get 325 grams to kilograms. Okay, what relationship do we need that involves grams and kilograms? I'm going to look at the top of the chart. Grams and kilograms. Grams and kilograms. So the prefix that is involved is just kilo. kilograms. 1 kilogram is equal to 1,000 grams. That's how we use it. 1 kilogram is equal to 1,000 grams. I'm going to write down that relationship. 1 kg equals 1,000 g. I'm sure you knew that. Now, we're going to convert that 325 grams of bismuth to kilograms. Okay, so start with the number that we got. We're going to convert it, so times, draw a line. The unit that we want on the bottom, hopefully you understand this by now, is the same as the unit that we started with, which is grams. So on our relationship, we want grams to be on the bottom. So 1,000 grams goes on the bottom. And that means the thing that goes on the top of this conversion factor is the other part of the relationship, the 1 kilogram. We're going to go ahead and write 1 kilogram on top. Okay, the unit that cancels out in this this work so far is grams and grams. We are left with kilograms, and that's what we wanted to do. We wanted to convert this to kilograms, this bismuth. So what we have is 325 times 1, which is going on the top. And then the thing that goes on the bottom is just the 1,000. That's the only thing that's on the bottom. And then we have kilograms. So we just want to simplify this. 325 divided by 1,000, if you type it in a calculator, we get 0.325, which makes sense, right? And that's kilograms. So we have the bismuth. And then we have the lead. The lead is right here. Okay. And it wants to know what is the total mass of the mixture if you combine them in kilograms. So the bismuth plus the lead, okay, bismuth plus lead would be the total mass. So bismuth was a 0.325, we just calculated it, and lead is 2.500 kilograms. The total is let's see, 0.325 plus 2.500, right? And what I'm getting is 2.825 kilograms. And you know, since they're both kilograms now, you can add them together. If they're not both kilograms, you can't add them together. It doesn't work that way. Okay, so you know, this one is just advanced because you gotta think a little bit about what you're working with, and it's not just, you know, convert this to this. You just think about it a little bit more. So for number 6, it's the same deal. You can go ahead, try that, and see if you got the right answer. Just go to Schoology, hover over the things that says hover for the answer, and then you can see if you got it right.